All right, hi there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with 7.5 today. We're getting into what are called trigonometric ratios. Trigonometry is the study of right triangles, and actually what's kind of cool is it's like trigonometry is the source of like electronic waves, sound waves. It's basically just like a unit circle. It's basically like using right triangles and measuring their coordinates on there. So if you think about like a sound wave or like an electromagnetic wave, it follows like a sine function graph, which is kind of interesting. So it is useful, more so down the line, but we were just introducing the basics of this. Okay, so it's going to be brand new, so it's going to feel weird, and it's going to seem like, is that it? It's kind of like a weird, it's just a ratio. It's basically a ratio of different sides of right triangles. Okay, and so for the warm up, it says write SOHCAHTOA. Say SOHCAHTOA. It says write SOHCAHTOA 6 times, and I want you to literally do that, okay? Like don't just do it. I promise it's useful. It's probably the most useful acronym we use in geometry, and it will help you to remember, the trig function. So go ahead and do that. All right, we will come back to that in a second here. I'm not going to write them out because I'm the teacher. I don't have to. So let's get into what these are here. Trigonometric ratios that's our ratio of the lengths of two sides in a right triangle. What kind of triangle? All right. And the three main trigonometric ratios, say trigonometric, okay? It's going to be their sine, say sine, cosine, say cosine, and tangent, say tangent. Okay, those are the main trigonometric ratios. There are variations on that. There are like inverse sine, inverse cosine, stuff like that. But these are the big ones here, okay? All right, now we're going to go back to SOHCAHTOA, okay? Say SOHCAHTOA. All right, so SOHCAHTOA, it's a shortcut. It kind of explains what these ratios are, okay? So we have this little thing down here. This is theta, okay? Theta is a Greek symbol, and it stands for an angle, all right? So this is theta. So what we have here is we have the side opposite theta, adjacent to theta, and then we have the hypotenuse, okay? So I like to say, like, adjacent is ADJ, opposite is OPP, and then hypotenuse is HYP, okay? So basically, sine, cosine, and tangent are just, like, ratios of these sides, okay? So sine, what do you think the O and the H stand for in sine? Well, it's going to be opposite over hypotenuse. Okay, that's literally all it is. Actually, I'm going to write it out so we don't kind of learn that here. Hypotenuse, oops. Okay, what do you think cosine stands for? It's going to be adjacent over hypotenuse. Okay, it's literally in the SOHCAHTOA thing, okay? What do you think tangent's going to be? It's going to be opposite over adjacent. Okay, and so the benefit of learning that acronym is you never have to memorize the ratios. It just kind of spells it out for you, okay? Another thing that we need to kind of know here is that the hypotenuse, the what? Hypotenuse is never an adjacent side. The hypotenuse is always across from what angle? The right angle. So the hypotenuse is never the adjacent side, okay? All right, let's get into this here. So let's do some examples. I do not like this. Today we're focusing on tangent, so we're just going to be doing the TOA of SOHCAHTOA, but I'm not going to use this box. These are garbage. I don't like them. They're from the book, and the book is not great. So, all right, so let's talk about, so we're looking for tangent of S and tangent of R, okay? So let's start with S here, okay? So here's S. So we need to find, tangent, like we talked about, tangent of theta equals opposite over adjacent, SOHCAHTOA, okay? So which side is opposite of S? Hopefully you said 60, right? Opposite of S is going to be 60. Which side is adjacent to S? 25 is adjacent to S. And this would be the hypotenuse over here, right? Cool. So literally we're going to set this up. We're going to do tangent of S equals opposite over adjacent. What's the opposite? What number is that? 60. Or what's the adjacent? 25. okay? If we divide that in our calculator, it's literally just a ratio. It's just like comparing the length of the opposite side of the adjacent side. And when we simplify that in our calculator, we get 2.4. So the tangent of S equals 2.4. All right, why don't you guys go ahead and you can pause the video and try to find the tangent of R, or you can keep watching and we'll go through it together here. So here's R, it's kind of cut off there. So we need the opposite over adjacent for R. Which side is opposite of R? Opposite of R is going to be 25. And what's adjacent to R? Adjacent to R is going to be 60. So it's kind of the same thing, but we're going to flip it a little bit. So we got tangent of R. Remember, it's opposite of adjacent, right? Opposite over adjacent. So what's opposite of R? 25. And what's adjacent to R? 60. So it's basically the same ratio, just kind of flipped around. And we're going to use an approximately symbol because we have to round this. And you should have gotten for a number 0.42. Okay, whenever you have to round, you want to use an approximate symbol because we're making it less accurate by doing some rounding. Okay, and that's all it is. It's kind of weird. Like, that's the answer. It's just like, it's saying what angle, it's saying like, what's the ratio of this angle with these dimensions for the opposite and adjacent sides. And that's all it is. Okay? All right. Let's see here. Why don't you guys go ahead and try this? No, we'll do the next one together here. Okay, so finding a leg length, okay? It says find the value of x, make sure that your calculator is in degrees. Make sure you come talk to me if you have a question about that. I can help you. So this one's a little bit different, okay? This time we're not looking for like the ratio. We're going to use this angle, which is 31, and we're going to solve. We can actually use like the tangent ratio to solve for missing sides, okay? So we're going to still use, what was the tangent ratio again? Tangent of theta equals what? It's opposite over adjacent, right? Okay, so you'll see here, the usefulness of the tangent ratio is we can actually use that ratio to like solve for missing sides, okay? So what angle are we using here? We got tangent of 31 equals, what's the opposite side of 31? We got 17, and what's the adjacent side of, this is opposite 31, adjacent is going to be x, right? We got 17 over x. All right, we need to solve for x now. How do we do that? Well, we're going to create a proportion here. We're going to cross multiply, okay? So what I'm going to get is I'm going to get x times tangent of 31 equals 17 times 1 is 17. Now, this is weird, right? We have x times tangent of 31 equals 17. How do I get x by itself? Well, it looks like it's multiplying by tangent of 31. Is tangent of 31, like, is that a variable or is that like a number? It's actually a number. Remember how we calculated up here, like, tangent of this variable, it was like 2.4, right? 2.4. This is actually a number. So it's just like pi or e. We can actually, if we're multiplying by a number, we just divide by that number. It's kind of weird that it's like tan 31, but tan 31 is an actual a ratio. So we can divide by tangent of 31. So if we divide 17 by tangent of 31, we're going to get approximately 28.29. And that's it. Actually, I'm going to write over here, opposite 31 equals 17. It's a good idea if you're not sure. I should have done this before. I didn't see it in my notes. To write out, if you're not sure, like, kind of getting the hang of this, just writing out, like, opposite, adjacent, and hypotenuse of that angle. That'd be a good use of your time, but okay. All right, so that was the examples we've done so far. Why don't you guys go ahead? I'll leave it zoomed here. Why don't you guys try 1, 2, and 3? Actually, there's 5 questions left you should be able to try to do. Why don't you guys go ahead and see how you do and try these. Okay, tangent of B and tangent of C. Let's do this. All right, so we're still learning here. So we're doing B first, okay? So we need, remember, tangent equals opposite over adjacent, right? TOA. Okay, so let's go ahead and list these. Let's make it in the habit this in case we're confused, okay? So what's the opposite side of B? Well, the opposite side of B is 48. What's the adjacent to B? The adjacent to B is 14. 50, remember, is the hypotenuse, so it's not going to be that one. Okay, so we can set this up now. We can do tangent of B equals, what's the opposite of our adjacent going to be? It's going to be 48 over 14. And if we go ahead and we plug that in, it's going to be an approximation. We have to round, so we get 3.43. And that is the ratio. All right, how about, let's use a different color here. Let's find C. Okay, what's the opposite of C? Opposite of C is going to be 14. And the adjacent to C equals what? 48. And again, we're going to do tangent of C equals, we have opposite over adjacent. You can see it's just going to be flipped here. 14 over 48, which is approximately 0.29. Okay? So, I didn't really mention in the original problems, but if it helps you to list these out like this and kind of like set it up that way, that is a totally good way to do that. All right, number 2 down here is very similar to what we were kind of doing before, where we were solving for the missing length here. So, we have 62 degrees. What do we have here? We have h and 100 feet. In relation to 62, what are those? Are those opposite, adjacent, or hypotenuse? Well, the hypotenuse is over here, and so this is going to be the opposite of 62, and this is going to be adjacent. So if we have opposite and adjacent, I know this whole chapter, this whole section is about tangent, but we want to think about what we have here. We have opposite and adjacent, so we're going to use what trig ratio? We're going to use tangent. So tangent of 62 equals what over what? H over 100. Okay. How do we solve this now? Well, we put tangent of 62 over 1. We cross multiply. So we have h times 1 is h. And then we have, okay, when you're writing this, put 100 in front, okay? Because when you plug in tangent of 62 and then you put 100, it's going to like kind of mess it up on the calculator, okay? And then so when you get this, we're going to get h is approximately 100 times tangent of 62 should be approximately 188 feet. Awesome. Okay, let's see these last examples here. All right, here we go. More practice. Okay, are we looking for the tangent or are we looking for a side length? We're looking for a side length, so we're going to be using, we're going to be using tangent, but we're going to be solving for x here, okay? So again, we should be able to kind of do this quickly here. We have tangent of 30, right? 30 degrees is the angle we have. Equals, what's the opposite over adjacent going to be? It's going to be square root of 3 over x. Put tangent of 30 over 1, cross multiply. We get x times tangent of 30 equals 1 times square root of 3 is square root of 3. How do I solve for x now? Remember, tangent of 30 is a number. Yeah, so I'm going to divide by tangent of 30. Okay, these are going to cancel. We get x is approximately 3. It's kind of weird. That's going to be just 3. It's actually equal to 3. I think this one was kind of weird because square root of 3 is going to be... I think tangent of 30 with the special right triangles will come out to a nice number, so it should be equal to 3. All right, last example. We got 2 more. Oh, man. All right, here we go. So, why don't you guys, if you have been watching for a little bit, why don't you guys pause the video, see if you can do these last 2 on your own? Okay. So, same thing here. We have tangent of 63 equals what over what? 13 over x. Put it over 1, cross multiply. We have x times tangent of 63 equals 13. Divide by tangent of 13. Sorry, tangent of 63. We get x is approximately 6.6. And the last one, we have this one here. We have 59, tangent of 59. And you always want to ask yourself, what do we have here? But x is opposite, 21 is adjacent, so we are going to use tangent, which is opposite over adjacent. So tangent of 59 equals what over what? X over 21. Put it over 1, cross multiply. We get x equals 21 times tangent of 59. Remember to put the 21 in front, or else it's going to mess it up on the calculator. And we get x is approximately 34.9. All right, hopefully that was a good amount of practice with tangent. Thank you for watching. Have a great day, and we will talk soon.